Hello friends, good afternoon. Myself Dr. M. H. Chennaya. In today's presentation for this YouTube video, we are having the section of a square pyramid. And the question for today's video runs like this. A square pyramid having side of base 30 mm and height 65 mm resting on HP with an edge of base inclined at 45 degrees to VP. So there is a square pyramid, it is resting on HP such that one of the base edges is at an angle of 45 degrees to VP. Is cut by a section plane. The section plane we will think over later. First of all, let me write down the top and front views of the pyramid for the given condition of the base. Friend, it is a square pyramid and all the four sides of the base are equally inclined to VP. So this is a special case of a problem. That is, if you have a square like this, the side of that is 30 mm each, and all these, one of the edges they have given you. So say this edge is at an angle of 45 degrees to VP. Friend, very obviously, when this is at 45 degrees, all of the other three edges, namely edge 1, edge 2, edge 3, etc., they will all be at the same inclination to VP. So for the same problem, it can be stated in two different ways. That is, the pyramid resting on HP with two of the adjacent sides of the base equally inclined to VP, or all the four edges of the base equally inclined to VP, it is one and the same. So friends, let me mark this as A, B, C, D, A, B, C, and this is small d. And friends, here, this is the top view of the base. And if I join these diagonals, AC and BD, they meet at a common point. That is called O, the vertex. So let me obtain the corresponding front view for this condition. So exactly, we are going to get a straight line on the xy, which you would call it as A dash, B dash, D dash, and this is C dash. Friends, this is O. The height of the pyramid is given to be 65 mm, and hence I write a vertical line through this, the center of the base, and call it as O dash, the front view of the vertex. Join that to all the corners of the base. So this is one slant edge, second slant edge, this is third and fourth. So I got all the four slant edges joined to the vertex O dash, and the height of this solid is given to be 65 mm. So we need to mark all these, the height of the object, side of the base, etc. Friends, you got the front and top views of the given pyramid, and let us see how the section plane is cutting the solid. A vertical section plane, friends, a vertical section plane is just like a vertical thin plate, a thin blade which is perpendicular to HP, or it could be even at an angle to HP. So friends, hey Lakshma, so this is at an angle to HP. So it is seen as a line in the top view. Friends, what do we do here? For this section plane, it is seen as a line in the top view, and hence I am going to draw that section plane at the given distance of 10 millimeter from the axis and towards the observer. I call this as section plane SS, and is at a distance of 10 millimeter from the axis. So I just mark it as 10, 10. So friends, if you observe this section plane SS, it is seen as a line at a distance of 10 millimeter from the vertex. Now friends, I want to just mark all these on the front. So the base of the solid is cut here. Similarly, the base edge BC is cut here, and the slant edge OB is cut here. So basically, there are 3 points where the object or the section or the solid is cut here. So let me project this. It is on AB. So write a vertical line from here. It is cutting the base at this point. Similarly, on BC, it's going to be another point here at the same distance. And friends, it is also cutting this slant edge OB. But if you see here, if you see the slant edge, so both the slant edges OB and this top view, they are in the same line. Hence, to obtain this point on this OB, we are going to get the end view by drawing a line x1, y1 parallel to that, and here I obtain the side view of this. This will be at an angle of 45 degree to obtain the side view. Friends, I transfer all these lines and obtain the end view. So friends, here you will have point 1, this is second, and this is going to be third. And whatever the view we are going to get here will be just identical to the one we have got in the front view. So this is going to be the side view. So this is point D double dash in the end view, and this is B double dash on the other end, and here you got A and C, A double dash, B double dash. Friends, you got all the 4 corners of the base, join them by straight line. This is how the object looks in the end view. This is all double dash, O double dash, and this is O1 double dash. Friends, I am making this construction to obtain the position of this point where the section plane is cutting OB. So friends, from here I transfer that point to here by horizontal line, draw a vertical line from there. This is cutting the edge O double dash, B double dash at this point. From there, I write a horizontal line to cut O double dash, B double dash at this point. So friends, we have got 3 points, 2 on the base edges AB and BC. So I will call this as 1, this point as 2, and this point as 3. So totally there are 3 points, 2 on the base edges, 1 on the slant edge. Please join all these by straight line. So I am going to join them by straight line, and we have got a triangle here 1, 2, 3. I am going to section that or hatch that by lines inclined at 45 degrees to the horizontal. Friends, now we have got the front view with the section. We call this view as sectional front view, and this is the left hand view, the view obtained on the right profile plane, and this is the top view. Friends, in the top view, you have to darken this at GC, AD, DC, and up to the section plane here, and this set up to here. So this will give you the top view, TV, the sectional front view you have got, the left hand view you have got. Finally, friends, if they ask you in this question, what is the true shape of the section? The true shape of the section is this figure 1, 2, 3. So I will show it as true shape, TS, true shape of the section. True shape. Just to So friends, this is the complete solution for the problem. Thank you for watching.